A square is a parallelogram that is a fusion of a rectangle and a rhombus. So if you took a rectangle and a rhombus and they had a baby, it would be a square. So a parallelogram with 4 congruent angles and 4 congruent sides would be a square. So if all of its angles are congruent, all of its interior angles are congruent, they'd all add to 360, and 360 divided by 4 would be 90. So each angle is a right angle, 4 congruent right angles if it's a square, and then all 4 sides are congruent. So the opposite sides and the consecutive sides are all congruent. So squares have all of the properties of a parallelogram, all of the properties of a rhombus, and all of the properties of a rectangle. So all the properties of a parallelogram. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary, and the diagonals bisect each other. So they're cutting each other in half. Then it has all the properties of a rhombus. So the consecutive sides are also congruent. So all 4 sides are congruent, and the diagonals are perpendicular. So these are all right angles. And then all the properties of rectangles. So the diagonals are going to be congruent. So that means that not only are just these halves congruent to each other, but these, all 4 of these pieces are going to be congruent. And I also forgot a property of the rhombus. So the rhombus, these diagonals are going to bisect those opposite angles. So this purple diagonal is bisecting this right angle. So this half and this half are going to be congruent. So if you take that 90-degree angle and divide it by 2, that means each of these is going to be a 45-degree angle. So what we have here is, in a square, this is really cool because it's a connection, connecting what we know about triangles to what we know about squares. It's so exciting when it all comes together. I love geometry. Just a plug for, my love geometry. These are all isosceles right triangles, and these diagonals are bisecting these angles, making them 45-degree angles. Oh my Lanta, we just created a whole bunch of 45, 45, 90 special right triangles. Oh, how fun is that we get to never forget special right triangles. So S root 2. If you take the short side, take the legs, and multiply it by root 2, that'll give you the hypotenuse. Or vice versa. If you know the hypotenuse, you're going to divide by root 2 to get the short side. So S root 2. Yay! Squares are amazing. Everything good happens in a square. So a square is like a fusion of a rectangle and a rhombus. It has all the properties of a parallelogram, because it's still a parallelogram, all the properties of a rhombus, all the properties of a rectangle. So if you think about this flowchart, which we'll fill out later, so there's parallelograms, and we learned yesterday about 2 special types of parallelograms, rectangles and rhombuses, and then rhombi. And then if a rectangle and a rhombus came together, we'd have a square. So square is all 3. It's a parallelogram, it's a rectangle, and it's a rhombus. So notice these arrows work in a certain direction. If something is a rectangle, it doesn't necessarily have to be a square. But if it's a square, it's definitely always going to be a rectangle. Just because something is a rhombus doesn't mean it has to be a square. But if it's a square, it is definitely a rhombus. It is always a rhombus. So square is always a rhombus. A rhombus is sometimes a square. A square is always a rectangle. But a rectangle is only sometimes a square. A square is always a parallelogram, but a parallelogram is only sometimes a square.